Greetings class and welcome to Friday, April the 10th. In this video, I'm going to do a few announcements and then move into some of the content for the course that's in chapter 12. First of all, I just want to make a couple of announcements about the test. Number one, exam number 3. I know it was difficult moving from an in-person, face-to-face course to an online environment, and the test using some of the tools that we had to use for that became a little more difficult. I understand that. So there are two things I want you to know. Number one, all of the questions were not graded in the points that you saw in the score after you took the exam. So the automatic grading was for the first 20 questions. The last 3 questions they were problems are worth 40 points. So in those questions, I'm going through the exam right now and manually grading what I see as responses to those questions. So whatever you saw in the exam as your score did not indicate your final test grade. It was just prior to those last 3 problems being graded. After I grade those, however, I am going to have test corrections next week. And I'll have another announcement to give you some specific instructions about those, but they will be due next week. And if you want to make test corrections on the problems that you uh, got wrong, some of the things that you saw in the exam that you misunderstood or whatever, you can make those corrections and send them to me and submit those. The main focus of these corrections are going to be on the multiple choice questions, not necessarily the problem questions, because in order to grade the problem questions, I will be revealing some of the responses that are correct and incorrect and giving you direction on those. Multiple choice is not that way. You can go back, look into those, and explain to me what you did wrong and why the problem was wrong. And those, for those multiple choice questions, we can add back points. So that's number one, that's the test. And then I want to mention Chapter 12 differential analysis documents are available right now. In this particular module, we have a differential analysis demonstration problems document, which is the Word document, and then a spreadsheet or worksheet in Excel, which is a solution, and then the PowerPoint itself. I'll be getting to the PowerPoint here in just a second, but before I do, I want to remind you of two important dates, 2 important assignments. First is the chapter 10 and 11 homework that's due tonight by 11:59 p.m. That's in Connect, and it's here in this particular module in chapter 10 and 11. So if you go back to that module, you'll see that homework assignment. Also, don't forget that we have a second week's discussion now available here in week ending April 5th. Again, like last week, I want you to basically respond to my questions. For this week, I'm not asking you to respond to each other, just respond to my questions. So if there are, I believe, 3 questions here in this week's discussion. Again, this is for attendance participation points, and I need you to go into that discussion, respond to those 3 questions, and make sure that you submit those. That should be done by 11:59 p.m. tonight. Okay, so those are the 2 assignment announcements that I wanted to make. Getting back to where we were in the modules, um, we're working on chapter 12 right now. And so, what I would like to do at this point is just talk a little bit more about the content in chapter 12 by going back to this PowerPoint. We've talked about a couple of ways we use differential analysis already, but one of the ways we haven't covered yet is preparing a make or buy decision. That is, if you are an if you are a company who's manufacturing several components that go into another, your final product, that would be called vertical integration. That is, you're making the components, you're putting those into the final product, then it's being assembled and sold. Um, One of the questions that we have in differential analysis is about how that works. Are we able to take advantage of some outside parties who may be able to introduce economies of scale to the manufacture of some of these components that we use in our product? Economies of scale may be appealing, but we also have to be careful because we don't want to give up control over quality issues that may be necessary for the company to maintain its competitive position in the market. So the make or buy decision, this is an example of one. The Essex company manufactures this part 4A that's used in one of its products, and the unit product cost of the part is as follows, and they have this broken down into all different components. Total unit product cost is $30 per unit. The question is this, the special equipment that's used to manufacture the part has no resale value. And then the total amount of general factory overhead, which is allocated on the basis of direct labor hours, would be unaffected by the decision. The $30 unit product cost is based on 20,000 parts produced during the year, and this outside supplier is offered to provide us the 20,000 parts at a cost of $25 a part, should the company stop making the part and buy it from the outside supplier. So this, on the surface, this is less than what we've calculated as a unit cost right now, and it might be appealing, but we need to do the analysis. So in the make or buying decision, we're going to look at avoidable costs. What does it cost us? That what cost can we avoid if we buy the product instead of making it? Well, the avoidable costs that we can identify are the direct materials, direct labor, variable overhead, supervisor's salary. The depreciation of the equipment will be a sunk cost, that won't change. And then the allocated general factory overhead won't change either. In fact, they told us that back here. They said whether we make it or buy it, the overhead, general factory overhead costs won't change. So when we go through the analysis in the make or buy situation, the cost of 20,000 units is going to be, once we eliminate the irrelevant costs, which are the allocated general factory overhead and depreciation, we have less cost to make the product or make the part than it would be to buy. So buying 20,000 of these units at $25 would actually be 500,000, but we can make those considering only the relevant cost for 340,000. That means that we do not want to buy the product. We want to continue to make that. So, like they said here, depreciation is a sunk cost. It simply spreads it out over the life of the equipment. And then the general factory overhead, uh, like I said a moment ago, will continue unchanged even if we don't make this product. Therefore, this is um, a sunk cost and something that's not relevant to our decision. So given that the total avoidable costs are less than the cost of buying the part, the company should continue to make it. That's the ultimate decision that we have here. So make or buy decision is one of those important decisions. We won't be going through that in the example today, but it is one of those that you may see again in the future. Now, opportunity costs are what we talked about before in the last video, and we've talked about these in other chapters, but an opportunity cost is something you give up in order to pursue some course of action. So, if the space that we had dedicated in the factory to this manufacturing of Part A or Part 4A, if that space had an alternative function, the opportunity cost would have been equal to what we could have derived from another alternative use of the space. So we didn't identify that, but if it is there, that opportunity cost would be factored in. Then what we want to do here is look at whether or not we should accept a special order. We will look at one of these today in the example problems. So a special order is by definition a one-time event. It's not something that's ongoing. Somebody may contact the company and say, we would like to get a special order arrangement where we have, we're going to buy X amount of these products. Typically, they're going to pay less than the standard going rate. Now, when we analyze these kind of options, we're only going to consider incremental costs and benefits um, because you're going to have the cost of manufacturing overhead anyway. You're still going to have those whether you do the special order or not. So here's an example. Jet Inc. makes a single product whose normal selling price is $20 a unit. A foreign distributor offers to purchase 3,000 units for $10 a unit. This is a one-time order that would not affect the company's regular business, and the annual capacity is 10,000 units, but Jet is currently producing and selling only 5,000. So they have the capacity to make these units if they want to. So the question is, should they accept the offer? So we're going to look at this contribution statement before considering the special order. Now, typically, what we're making now, so we're at production of 5,000 units now at the regular price of $20 a unit. So they have revenue of $100,000, and then we have these variable costs that are involved, and that gives us a total variable cost of $40,000, which is $8 per unit. We're deducting that from the sales to get the contribution margin. So when we look at the incremental costs, what we want to think about are the incremental revenue compared to the incremental variable cost. Back here, here's the incremental variable cost, $8 a unit. And the incremental revenue is going to be the units we sell to the special order at the price they're offering to buy them at, which is $10 a unit. So we have $30,000 in incremental revenue. We have, with 3,000 units times $8 variable cost, we have $24,000 and a financial advantage of accepting the order of $6,000. This also assumes that fixed costs do not change. We can't avoid those. And that variable marketing costs must be incurred on the special order. So that's a special order. The last thing that I want to talk about here, because we're going to look at this in just a moment, is understanding the most profitable use of a constrained resource. A constrained resource is one where we have a potential bottleneck in the production area. This is called or considered to be a volume trade-off decision. So companies make these when they don't have enough capacity to produce all the products and sales volumes demanded by customers. In these situations, there must be a trade-off somewhere. And so this is what we're going to consider. How do we determine what that trade-off is? So if we have a particular resource that's limited, that will restrict our ability to meet unlimited demand. So that is considered to be the constraint. If it's a machine or process that's limiting the overall output, we're going to call that a bottleneck and basically consider that to be the constraint. Fixed costs are usually not affected in these situations, so product mix will maximize the total contribution margin is what we want. Whatever product mix will maximize the company's total contribution margin, that's what we want. We should not necessarily promote products that have the highest unit contribution margin, rather the total contribution margin is maximized by promoting products or accepting orders that provide the highest contribution margin in relation to the constrained resource. In other words, what this means is you don't just look at the contribution margin of the product and say, okay, we want to do this. Rather, we want to look at uh, orders that provide the highest contribution margin in relationship with the constrained resource. It is possible to have a product with a high contribution margin, but one that does not take advantage of the constrained resource in the way that another does. All right, let's move on here and take a look. Instant Company produces two products, and selected data are shown here. They have the selling price, the variable expenses, the contribution margin, and then they have the current demand per week in units, the contribution margin ratio, and then the processing time required on the machine, A1, for input. Machine A1 is a constrained resource, so being used at 100% of its capacity. There is excess capacity on all other machines. Machine 1 has a capacity of 2,400 minutes per week. Should Ensign focus its efforts on product 1 or 2? So here we have these two products and the difference between them. So the question is, how many units of each product can be produced through machine 1 in 1 minute? The answer here is 1 unit, product 1, 2 units of product 2. Which one is going to generate more profit for the company using 1 minute of machine time to process product 1 or product 2? So the answer is product 2 with 1 minute of machine time. They could make 1 unit of product 1 with a contribution margin of $24, or 2 units of product 2 with a contribution margin of $15 each, meaning that the total contribution in 1 minute for product 2 is $30 rather than 24, so it's higher. So we want to really look at how that constrained resource impacts contribution margin and the profitability. Okay, what I want to do here is, this is an example. They're going through this, and what they're going to tell you is, okay, here's the contribution margin per unit, and then they're dividing that by how long does it take to produce 1 unit. In product 1's case, it takes 1 minute. So you have a contribution margin per minute of $24. But in product 2's case, it takes a half a minute. So you have $30 of contribution margin for every minute. So what we say from looking at this comparison is that they should do product 2 instead of product 1. So they can maximize contribution margin by making product 2 first to meet customer demand, and then whatever capacity is left they could use for product 1. Here's how the calculations look. We start with the weekly demand for product 2, the time required, the total time required to make the product, the total time that's available. Then we subtract out the time used to make product 2. We have some time available for product 1, and that would be divided by the time required per unit to give you the production for product 1. Okay. And then based on this plan, we'll produce 2,200 units of product 2 and 1,300 units of product 1, and the contribution margin will look like this. The total contribution margin is 64,200. Okay, I want to really stop here with this. This is pretty much the end of what we want to do anyway. But I want to move and shift focus over here to these demonstration problems, because while this information in the PowerPoint is very good, I want to get to a direct application of what we're talking about. So the first, and by the way, these documents are loaded in Canvas, and you can unload or download them, review them, print them, work on them, or whatever. Problem number 1 that we have here is Country Curtains Company makes fashionable window curtains and valances. Data concerning the company's three product lines appears below. And these differ, you can see, in the selling price per unit, in the variable cost per unit, and the amount of fabric they use and the sewing machine time that they use. And the questions are listed below. So number one is, if we assume that the total fabric available is a constraint, how much contribution margin per foot of the constrained resource is earned by each product? So let's go over here to this problem that I have in Excel. We'll go back here to the beginning. This is number one right here, and I have a table set up in the Excel document so we can kind of take a look at this. Number one, we want to really consider the selling price per unit, the variable cost per unit, and then do a contribution margin per unit, just like they did in the PowerPoint. So for the 6-foot curtains, when we go back to this document, we have a $50 selling price. And so I want to go back here and say, okay, we have a $50 sales price. We have variable cost of $26 in the document based on this information here. We have a contribution margin then. We're going to take the $50 minus the 26 of $24 per unit. When we manufacture this 6-foot curtain, we need 6 feet of product. So we have 6 feet of fabric. The contribution margin per unit of constrained resource. Now we're assuming the fabric is the constrained resource. We're going to take the $24 divided by 6 to come up with a $4 per yard, or per foot, not yard, I'm sorry. $4 per foot for this constrained resource of fabric. Okay, we want to do that comparison for the 3-foot curtains too. When we go to the 3-foot curtains, we find out they have a selling price of $40 a unit, variable cost of $16 a unit. That gives us a contribution margin of $24 again. But this time they use 3 feet of the fabric. So now, if we're looking at the constrained resource and comparing it to contribution margin, we have an $8 per foot contribution margin for the constrained resource. Okay. Going over to the valance, and again, we're just taking these numbers from this table right here. We have a $55 selling price, or the table up here, $55 selling price, a $25 variable cost per unit, and that means we have contribution margin of $30 per unit. Now, the feet of fabric required in this case is going to be 4 feet right here. So we take the $30 divided by the 4 feet, and we get $7.50 per foot as a contribution margin. So the question then is, okay, of all of these products, which one provides the most profitable use of the fabric? And this would be the 3-foot curtains, because the contribution per margin, or contribution margin per unit of constrained resource. I'm going to make this so it will wrap. That contribution margin per constrained unit of constrained resources is the $8 per foot. And that's the answer. So you can look at this side by side and see this. The greatest contribution margin per foot here is the 3-foot curtain. So that's where we would want to focus our efforts, on the 3-foot curtains. For requirement number 3, it says here, what happens if we have a labor shortage and it requires us to cut back our production, so much so that this new constraint has become the total available sewing machine time, so that this new constraint has become the total available sewing machine time. Close this. How much contribution margin per constrained unit of resource will we have? So basically, they're asking the same thing, but they're asking it about a different constrained resource. This constrained resource is based on the minutes of sewing machine time because we have a labor shortage. So in this case, we're going to go through the same computations. We're going to say the $50 in selling price, the $26 in variable cost. We're going to have a contribution margin of $24. But now, instead of dividing this by the feet of fabric in the product, we want to know how much sewing machine time is there in this product. And according to the information that we've been given, the answer is there are 6 minutes of sewing machine time in this product. So we're going to take that $24 divided by 6 uh, to get $4 per minute of sewing machine time. The 3-foot curtains, we're going to have the $40 sales price, $16 variable expense, and again, we're going to have the $24 as a contribution margin, but now we have 8 minutes of sewing machine time for the 3-foot curtains. So we're going to compare that by taking the 24 divided by 8, and we find out we have $3 per minute of constrained resource for the 3-foot curtains. And then finally, with the Valance, we have a $55 sales price, $25 variable cost. No, variable cost goes here. And then we're going to take the difference between the two, $30, and identify that the Valance takes 16 minutes of sewing machine time. So now when we calculate the contribution margin per constrained resource, we get $1.88 for the Valance. Now this is based on the labor time, the amount of effort and time it takes to actually sew the curtains. So they ask us which product offers the most profitable use of sewing machine time. This case is going to be the 6-foot curtains. And the contribution margin per unit of constrained resource, I'm going to wrap that, will be $4 per minute. So we have $4 per minute of sewing machine time. Okay, not 44, 4. I got 2 there, but I did. Anyway, so that's the answer to number 4, $4 per minute. And then requirement number 5 asks which product has the largest contribution margin per unit, and why wouldn't this be the most profitable? Well, the one that has the largest contribution margin in this case is the Valance, and you have a contribution margin of 30 per unit. And again, I don't want 4, I want the dollar sign. Okay, so that would be the product with the highest contribution margin. And the question is, why wouldn't this product be the one that's most profitable over the use? Would be the most profitable use of the constrained resource in either case. It's because it takes more time to sew the Valance in the second scenario, and in the first scenario, it takes more fabric than it does for the 3-foot curtain. In other words, if the fabric is a constrained resource, you want to be able to use that most efficiently, which means you're going to look at the one that uses the least amount of that constrained resource. The same thing is true here. And you notice that the one that we chose uses the least amount of the constrained resource, is the sewing machine time. So that's the answer for number one, or for the first demonstration problem. The second one is a special order problem. And I want to go back to this document because I want to go through that and talk about what this is. Delta Company produces a single product. The cost of producing and selling a single unit of this product at the company's normal level of activity of 65,000 units a year is, and they give us this layout here of all of the cost, the direct materials, direct labor, variable overhead, um, fixed overhead, variable selling and admin, and fixed selling and admin. Normal selling price per unit is $40. The company's capacity is 90,000 units a year. Um, an order has been received from a mail order house for 25 units at a special price of $24 a unit. This order would not affect regular sales or the company's total fixed costs. What is the advantage or disadvantage of accepting the special order? And as a separate matter from the special order, consider the company's inventory, including 800 units of this product that were produced last year and that are inferior to the current model. The units must be sold through regular channels at reduced prices. What unit cost is relevant for establishing a minimum selling price for these units? Okay, so first of all, let's look at number one. Number one is going to require that we do some analyses and calculations. So I have all the data here on the second tab, special order problem. And what we want to think about are the incremental sales that we're going to have. So the special order offer has asked us to sell these at $24 a unit. We normally sell them for 40, but we're going to sell them at 24. And there's going to be 25,000 units. So we're going to multiply 25,000 times 24 to get the total incremental sales that we'll have, 600,000. I'm going to format this differently because I like the commas. All right, $600,000 in sales. When we look at direct materials, basically we're going to use this data that we have up here, the $7.50 per unit. So we have the 750, and we're going to calculate that times 25,000 units. We get 187,500. And then we look at direct labor, it's $4.60. And we're going to multiply that times 25,000 and formatting. You just do this and format this entire thing here. Okay. So now when we get to direct labor, we already had direct labor 460. Variable manufacturing overhead is 250 per unit. Now, because I'd entered that formula before, it basically took that formula down to the cell underneath it. But again, this is going to be the 250 times 25,000. Okay. We'll have the same thing here. When we look at variable selling and admin, the variable selling and admin is 2.75. So we take that times 25,000. Wait a minute. 25. There we go. And we have 68,750. And when we take this per unit amount, we're going to total up these costs for total incremental costs, and we have 1735 a unit. Overall, we're going to total these up for the 25,000 unit order. We get 433,000 dollars and 433,750. The financial advantage of accepting these orders is going to be the difference between the incremental sales and the incremental cost. In this case, $6.65 per unit, or the difference between 600,000 and 433, which is 166,250. So that answers the first part, that there is an advantage to taking the special order. And one of the ways I'd like you to think about this is that this is an advantage because you've already got the fixed costs of doing business that are being absorbed by other products. So you can offer this at a lower cost or a lower price and still uh, benefit the company overall. It wouldn't be the same as if you were selling it at $40 a unit, but you can sell it at a little lower amount and still improve your position. As a separate matter from the order, this is something that's a little different. Uh, Assume that they have inventory of 800 units of the product from the prior year that are inferior to the current model. The units must be sold through regular channels at reduced prices. What cost is relevant for establishing a minimum selling price for the units? Okay, for this particular issue, you have this old inventory that's inferior, that may be actually approaching obsolescence. You have the opportunity to sell it. The only cost that's going to matter to you here on a unit basis is the variable selling and an administrative cost. So $2.75 is going to be the relevant cost that you have to sell these units. So in other words, when a company has old inventory or old products, this is why they can reduce the cost so much and actually wind up benefiting from it. Because at that point, they're not looking at making a profit per se on the cost they've put into these products, but rather recouping whatever cost they've spent on that. So anyway, those are the two example problems. And this is the end of what I was going to do for today for chapter 12. On Monday, we'll have our regular WebEx meetings again, and we'll talk more about what's coming up in the week ahead. So take care, stay safe and healthy, and I look forward to talking to each of you next week.